Looking at density. So density is defined as the mass over the volume. And you can abbreviate density with this Greek letter, which is the letter rho, and mass over volume. You can also just use a capital D if you prefer. So let's work some problems. A copper penny has a mass of 3.18 grams and a volume of 0.35 cubic centimeters. Determine the density of the copper. So one thing that I find helpful is to underline the information that I have in the problem. So I have its mass, I have the volume, I want to know the density. So then I list what I know. My mass is 3.18 grams. The volume is 0.35, and I do take note of how many sig figs are in each value. My density is what I want to determine. So density is my unknown. I like to use a question mark. And then I like to write my basic equation, mass over volume. So this one doesn't need any rearranging because I'm solving for density. So now I can plug in my numbers and solve for density. My mass is 3.18 grams divided by 0.35 cubic centimeters. Can you calculate your density? Your calculator is going to give you a bunch of numbers. I've written down some, 9.0857. Notice your units don't cancel, so it's grams per cubic centimeter. But we need to worry about significant digits. So mass has 3 sig figs, and the volume, has 2 sig figs. So you need to round your answer to 2 sig figs. So I'm going to change my number to 9.1 grams per cubic centimeter, and that will be my density. Our next problem has us calculating the volume of a silver coin that has a mass of 14 grams and a density of 10.5. So V is my unknown, my mass is 14 grams, and the density is 10.5 grams per cubic centimeter. Our basic equation is density equals mass over volume. I find it most helpful to isolate the variable that I'm solving for. So I want V all by itself. So I'm going to multiply both sides by V, and I'm going to divide by density so that my volume is by itself. So density goes away and volume goes away. So my final equation, or I should say my working equation, is mass divided by density will give you volume. So now I'm ready to solve. I have my mass of 14 grams. So notice I always put units in my work, which means you should too. 10.5 grams per cubic centimeter. And we'll look at the units separately once we do the math. So 14 divided by 10.5 is a value of 1.3333. Now, let's first round this to the proper sig figs. Notice I have 2 sig figs for mass and 3 for density. So I'm going to round this to just 2 sig figs, 1.3. I haven't dealt with my units yet. I know it's volume, so I know it should be cubic centimeters, but let me show you how they work. So I'm just going to work with units down here. I have grams over grams per cubic centimeter. So my next step is to say grams times, this is a fraction, so I'm going to invert and multiply. So now you can see that your grams cancel and you're left with cubic centimeters. So now I can put my units in. I could put them in here too, and put a box around your answer and a smiley face because now you know the volume. Our next question asks us to find the mass of a piece of iron. It has a volume of 45 cubic centimeters, and they give us the density of 7.87 grams per cubic centimeter. So mass is what we want to find out. volume is 45.0, and density is 7.87 grams per cubic centimeter. So density equals mass over volume. I want mass all by itself. I'm going to multiply both sides by volume. So mass is by itself. I like my variable that's by itself to be on my left side, and I like to say density times volume. So solving for my problem, 7.87 grams per cubic centimeter times 45.0 cubic centimeters. Cubic centimeters cancel. Notice it makes it a little bit easier if you make it a horizontal line rather than a slanted line. It's just easier to catch. You multiply, and your answer will be something like 354.15 grams. Look back at your sig figs. I have 3 in each of them, so my final answer is 354 grams is my mass. Our last one is a conversion, and density is often expressed in kilograms per meters cubed. And I have the density of platinum as 21,450 kilograms per meters cubed, and I want it in grams per cubic centimeter. So my first conversion is 1,000 grams in 1 kilogram. And I know there are 100 centimeters in 1 meter. I will cube it when I actually do the conversion. So I'm going to start with what we're given, 21,450 kilograms, and I'm going to write 1 meter cubed. Notice I've made a horizontal line instead of the slant. Then let's deal with kilograms first. 1 kilogram has 1,000 grams in it. So my units cancel. I'm left with grams per cubic meter. My next conversion is using the 100, and I want centimeters in the denominator, so 100 centimeters with 1 meter on top, but it needs to be cubed. So I need to cube the 100. So my units will be meters cubed, meters cubed. On your calculator, it'll be 21,450 times 1,000 divided by 100 cubed. You should get an answer of 21.45. My units are grams per centimeter cubed. I have 4 sig figs in my original number and 4 sig figs in my answer, and so I'm all done.